Hey everybody, it's Miss A. Welcome back to part 2 of our week on inverses. We've got some extra information here for you. It's a short little video clip just to show you some extra tips and tricks on how to identify or determine if you have an inverse function. So our first thing that we're going to focus on is this thing called the horizontal line test. You guys probably think this sounds really familiar because you should all be familiar with the vertical line test. A vertical line test is when if you pass a vertical line over the picture that you're given, graph of whatever you're given, and it passes through the picture once and never touches the graph more than once, then you pass the vertical line test, you are a function. So for instance, this first graph is of a function, it passes the vertical line test. The second picture is also a function, it passes the vertical line test. But I'm talking today about the horizontal line test. And the horizontal line test is the same exact test, only now we're going horizontal. But we're not checking to see if we are currently a function. We are checking to see if our inverse would be a function. So what I can do is if I look at this first picture, you can see here that if I pass a horizontal line over this graph, it passes the horizontal line test because it never touches more than once. And because of that, it passes the test. So this function's inverse is also a function. All right. If we take a look at our second example of this parabola, yes, it is a function. Is its inverse a function? Well, if I pass the horizontal line over my graph, you guys can see that there are many places where I'm going to be touching this graph more than once, meaning that it is failing the horizontal line test and its inverse will not be a function. So this is a pretty neat, quick way for you guys to determine if the inverse is going to be a function or not without really having to do any math work. You can just use your eyes. So I have two more examples down here. The blue is the original function, and then the red is the inverse, and we're trying to decide if the inverse is a function or not. So this is a function similar to what we were seeing before. It's a parabola. So we've got, this is our original function. It does not pass the horizontal line test, meaning that its inverse should not be a function. If this is the picture of the inverse, you guys can clearly see that this does not pass the vertical line test. So it is not an inverse function. It's an inverse relation. Which is totally fine. It's just that, remember, we do like functions typically better in math than we like relations, just because they're more interesting and they have a lot more going on. Okay, if you take a look at this second example, this right here is the function y equals x to the third power. It's a cubic function. Yes, it is a function because it passes the vertical line test. Let's see if it passes the horizontal line test. Yes, it does. So as you guys can see, the inverse that has been graphed here in red is going to, in fact, also be a function because it passes the vertical line test. But as you can see, just doing the horizontal line test prevents you from having to create that inverse graph and then also deciding from there. So this guy does have an inverse function. So why don't you guys take a second and pause this video on this screen. And I want you guys to determine who passes the horizontal line test so they will have an inverse function. Take a second to hit pause. Okay, so now that you've returned to this video and you've taken a look at all of these pictures, let's decide who is going to have an inverse function because they pass the horizontal line test. Picture A, you guys can see fails the horizontal line test. So since they fail the horizontal line test, we are not going to have an inverse function. We're going to have an inverse relation. Picture B passes the horizontal line test. So we are going to have an inverse function. C, again, passes the horizontal line test, so we will have an inverse function. And D, passes the horizontal line test, so we will have an inverse function. Picture G, does not pass the horizontal line test. It fails, so we will not have an inverse function. And last but not least, H, does not pass the horizontal line test. It fails, so we will not have an inverse function. Hopefully you guys got 100 on that. Okay, last but not least, how would you check algebraically speaking if you aren't provided with a picture? Well, I'm going to go back to this part where we were talking earlier in the week, where we have this test, f of g of x and g of f of x. This is why we talked about composite functions before we talked about inverse functions, because if you are able to plug a function and its inverse into each other and they cancel, everything cancels out, and all you're left with is just a plain old x, then you pass the test. You are considered inverse functions of each other. If you don't pass the test, that's fine. It just means that you're inverse relations, that's all. But we like when we pass this test because we like, again, us mathematicians, we really, really like functions. So we're going to go ahead and give this a try. So I just wanted to show you guys two examples. The two examples that I'm going to show you are from our notes that we took in our first video. So this is problem number 1 from your notes that I just recreated here. Now you can see that they gave us the original function, we created the inverse function, and all I did so far was I set up f of g of x and g of f of x. And remember, another way that we can describe this function is g of x just by giving it a new name. We put it in proper function notation because we knew it was going to be an inverse because of what Delta Math was telling us. But anyway, we do have to test it forward and backwards. What one does, the other one has to undo, right? Like how adding and subtracting are always canceling each other out. We have to be able to cancel each other out. So let's go ahead and give this a try. I'm just going to move this so we have a little bit more room. All right, let's start with what we have on the left here. I plugged our function g into our function f here, and let's go ahead and carry out the order of operations and see what happens. So I have to distribute this 1/2. So 1/2 of 2 is just going to give me 1x, and then half of 16 is going to give me 8, and then I've got this minus 8 on the end that I'm going to bring down here. All right, if I combine like terms here, plus and minus 8 are going to cancel each other out, so I'm left with just an x. So far, so good. This is working out. But doing it one way is not enough. I have to be able to plug them into each other, vice versa. So if I'm going to do this and make sure that they are inverse functions of each other, I'm going to now take f and plug it into g. So that's what I set up over here. So again, I'm just going to carry out order of operations. I'm going to multiply everybody by 2. 2 times 1/2 is just going to give me a 1x. 2 times negative 8 is going to give me negative 16. And then I've got this plus 16 on the end here that I'm going to bring down. If I combine like terms, plus and minus 16 are going to cancel each other. I'm left with just an x, and take a look. It worked. So this is true. These guys are indeed inverse functions of each other. I'm going to do one more example that's a little bit more complicated. This was from the second set of problems that we did. It was number 3. And again, it's where we were given this function as the original, x minus 8, all to the 1/4 power, and then we found the inverse function, which was x to the 4th plus 8. So I've set up here f of g of x and g of f of x. Just going to scooch this up for you guys. And as you can see, what I did that's a little bit different from the original problem is instead of using parentheses, I used braces just because, brackets, just because there were so many parentheses in the problem that I didn't want to start to get confused. So this problem was quantity to the 1/4. Over here, this was quantity to the 4th plus 8, and then I was going to have to plug in something that had parentheses, so I was just trying to distinguish between the two different sets of parentheses. It's totally allowed. They're still part of that category. But anyway, let's figure out where we are even going to begin with this stuff. Well, inside here, we have to use grouping symbols, right? So inside of this set of parentheses, I've got to see what's going on inside here before I can deal with this power of the 1/4. So I've got x to the 4th plus 8 minus 8. So I'm going to rewrite this actually so it's a little bit easier to see. I've got x to the 4th plus 8 minus 8 all going on inside of these set of parentheses, and this is what I'm focusing on. So plus 8 and minus 8, these guys are like terms, so they cancel each other out. So really all I'm left with inside is x to the 4th power all raised to the 1/4 power. And as you guys know, the power of the reciprocal, 4/1 and 1/4, when we multiply, what happens? That's right, they cancel. So what am I left with? Just a plain old x. So that's awesome. So far, so good. Now let's reverse this process and plug f into g. So now I've got this plus 8 on the outside of this set of parentheses, all raised to the 4th power. I really need to see what's going on in here first. There's nothing I can do inside this parentheses. There are no like terms. I don't want to raise this to the 1/4 power because, again, remember, 1/4 power means 4th root. So I can't take the 4th root of all of this. That's just silly. There's nowhere I'm going to be able to go. But I am seeing power to a power. And power to a power means I multiply. And take a look. The power of the reciprocal is working in our favor here. 1/4 times 4/1. These guys are going to cancel each other out. So really all I'm left with is x minus 8. And then I'm going to bring down this plus 8 that I have on the end here. These guys are like terms. Plus and minus 8 cancel each other out. I'm left with just an x. And hey, this guy worked out too. So I'm going to make these notes available to all of my students. I'm going to share them out with the other teachers that are using this video as well, so you guys can have these and print them out if you would like. But why don't you guys check out the quizzes to reinforce these concepts? Thanks for showing up for video 2, guys. See you next week.